We are going to do the practical seasonal, interannual variability and long-term changes in mean sea level. And we are going to look at data from Western Australia, where I spent 3 very happy years of my life. Now, by the end of this practical, again, you're actually going to do some quite advanced things, but you'll see that the code is not particularly complicated. Now, I know it takes time, but just be patient, and really, actually, I could do all of these practicals in about 10 minutes once you get kind of good at MATLAB. So they're not particularly difficult, but I do appreciate that as you're learning MATLAB, it can seem quite complex, but the more you use it, the easier it gets. Okay, so let's go to Blackboard. Let's go to the practical sessions, week practical 3, and we are going to download the template. Now, remember previously you set up a folder, so please use the same folder. It should have a folder called code, which we can put the mean sea level template, and it should have a folder called data. So we can open the mean sea level there. It's really important to be organized. Always make sure you're working in the right folder. So you should always be in the code folder here. Okay, so you can have a read of the background there, but we're going to use 2 different data sources here. Data from the Permanent Service for Mean Sea Level, which is actually a facility run by the National Oceanography Centre in Liverpool, and then we're also going to use the Southern Oscillation Index, which represents El Nino, Southern Oscillation. So like before, go through, have a read of everything. Now be really careful to read everything, because often students have asked for help and it's often they just haven't read it properly, so just read everything. But like in the previous practical, we're going to start in exactly the same way. We're going to clear the workspace and clear the screen. I like to do this all the time. Let's just run this section just to make sure there's no variables that I could overwrite by mistake. Okay, like before, we're going to specify a SID, which stands for site identity. This time it's going to be the number 111, and that represents the Fremantle tide gauge. Again, I want to, once I've written all of the script here, I want to be able to just change that number to another site. There's more than 1,000 sites in the Permanent Service for Mean Sea Level, so once you've written this, in theory, you could apply, well, you can apply it to every one of those 1,000 sites if you wanted to. Okay, so the first step we're going to do is load in the PSMSL data. So let's click on the PSMSL link. We'll go here. Oh, I already had that open, sorry. Let's go back. Click on that link again. Don't know why that's not working. PSMSL. And there's a number of places you can go, but I'm going to go to the table here. I'm going to click order by, well, we could click by ID, and we're going to scroll down to 111, which you can see here is Fremantle. I'm going to click on the link there, and this tells us you can zoom in and out of the map. It tells you the latitude and longitude, and here's the data. So you can actually see here, this is monthly data, this is annual. You can see that sea levels are rising, but we're going to right click on here, save the link file as, and I'm going to save it to that folder. Now make sure you save it to the data, so it should be 1.rlr data. There. Now that data file is a text file, so actually we can drag that into a text editor and have a look at it, and you can see it's just got the decimal year, sea level height, and then some flags here which you can read about in the format page. So if you go back here, you can also read about the information, where the data's come from. So this has come from the National Tidal Centre. You can look at datums. This tells you the datums, chart datum, mean sea level, and various things there. So this is a really useful website. So we have the data now in our data folder. Okay, so now we're going to create a variable called file in, and this is going to be the file name. Now I've noticed for some reason when I saved it this time, it doesn't have a text variable, a text extension. Not too sure why that is. Sometimes it seems to, but it doesn't matter too much. Now what we're going to do again is we're going to combine strings and numbers exactly like we did last time. So that string will stay the same. Now we need to go back 2 directories, so that's the 2 docs. So back 2 directories from code, back 1 directory, then up into data. This 111 we can replace with SID, but we need to convert it to a string. So num to string, and then we can add on the bit at the end. Now for some reason mine hasn't saved it with a text, on some computers it does, but we can run that. We can generate a file name. Actually, sorry, we have to run the whole thing because I didn't run. And there you can see the file name is generated. Okay, now we can use the import data function. Now you can do this within MATLAB here, where you can actually import data, but I prefer to do it all from the command line because if I'm going to run this 1,000 times for different sites. Okay, so now we can import the data here. And we can run that section. And hopefully you can see now that the data is going to be brought in. So there, the data's brought in. Now what I'm going to do is just tidy it up. So I'm going to create 2 variables. The first is my decimal year. So it's year month is D. You specify the number of rows. So this is all the rows, semicolon, comma, the column. And that's going to bring in D. And then I am also going to bring in a what I'm going to call relative mean sea level, and this is going to be D shift column 2, and that is in millimeters. Now if you click on here, you can see there is some -999 values, so I'm actually going to get rid of those, and this is relatively easy to do. You can say relative mean sea level, but not all of the data, just the data that's equal to -9, -99999. I'm going to set as NaN. So we can run that, and you can see here now it's set all of those as -NaN. So actually you can see within a couple of minutes, it's quite straightforward. We have loaded in the data. So what we're going to do now is plot the data. So I'm going to bring up the figure function. I'm actually going to use units normalized. I think I explained this last time, but that sets this bit of the screen as 0, 0, the bottom left corner, that as 1, 1. So it's kind of like a percentage position. I just like to do this because it makes my figures bigger than just using the standard figure function. So this will be, it will set the figure up as sort of 10% along, 10% up, and then 80% of the width, 80% high. So we can run that. You can see, should see a reasonable size figure appearing. And then we are going to do the tile layout, tiled layout. I'm just going to have a 1 by 1. And then we're going to put on the next tile. I'm going to hold on, although I don't really need that, but I'm going to plot YM against the relative mean sea level as a black line. Let's just make sure that works. You can see I've probably spelt it wrong. Relative mean sea level. What did I put it as? So you should see, yeah, and there's the data. Now, like before, we're going to put on a X label, which is the year, Y label, which is level, and the data is in millimeters. I'm going to put a title. Because it's strings, it's always in quotes. Relative mean sea level. Like always, you can see there's no box on, so I'm just going to put a box on. I'm going to put axis box on. Sorry, the next one is grid on. And then finally, like we did previously in Practical 1, and actually, I'd always encourage you to cut and paste text. It saves you doing it before, but remember here we use this nice function to plot the, I think further down, to plot all the axes as bold. We can just cut and paste that across. So never write new code if you can just cut and paste it across. I'm a really lazy programmer. So let's run that, and you can see it's made our figure look much, much nicer. Okay, so now that we've done that, you can see actually this is quite quick. What we're going to do is we're going to separate sea level into its three component parts, like we saw in the video, a kind of seasonal cycle, that's what we call intraannual, an interannual, which is kind of year-to-year variability, and then the long-term trend. Now what we actually have to do is start with the long-term trend and work backwards. A long-term trend has this form y equals ax plus b. And so we can use the polyfit function. Polyfit, and we're going to polyfit ym, and we're going to polyfit relative mean sea level. Now this will come out as negative, as NANs, polyfit, unrecognized variable, or sorry, should see polyfit. Now this will come out as NAN because the data has, and for a linear trend we need a 1 on the end. Again, you can look it up. Now you can see it's NAN, so what I'm going to do is find everything that is NAN in relative mean sea level, and what this does is I will find which ones are, and you can see when it's a 1 it's an NAN, when it's a 0 it's not, or sorry, the other way around because I've done not. So what I can do here is just give it not all of the rows, but just the rows where there is not an NAN number. Okay, just going to comment that out so it doesn't show you, and now you can see we have a trend. So the trend is actually 1.7 millimeters per year, which is very good because most sea level data had a trend of between 1 and 2 millimeters per year over the 20th century, so I know that is right. Now what I'm going to do is call a variable called L for long-term trend mean sea level is the pol eval. So I'm going to give it the A and B. So this is the A and B. So the A is the trend, B is the intercept. I'm going to give it those values and then the YM month, and that's going to create me, I'm just going to comment it out again, but that's going to create me a data set of the linear trend, and I'll plot that for you later and show you what that looks like. Okay, now that I've got the linear trend, I'm going to remove that and I'm going to create an interannual mean sea level component. And what I'm going to do here is do a 12-month running mean to kind of get rid of the seasonal cycle. So I'm going to bring in the relative mean sea level, I'm going to subtract the long-term trend, and then I'm going to do a moving mean of 12 months. Now this is going to have NANs in, so actually what I'm going to do is I'm going to omit nans, so it kind of interpolates between the nans. So actually we're getting on very well here, and then the final component is to create a seasonal mean sea level cycle, and that is simply the kind of measured monthly data minus the interannual component minus the long-term mean sea level component there. Okay, so actually we're getting on incredibly well here. And what we can do, sorry, I think I've copied these into the wrong lines, but that doesn't matter too much. Now what I'm going to do is plot the, sorry, that should be, I think I've got these slightly mixed up, but that doesn't matter too much. I'll just copy these up to the correct lines. So I've run ahead of myself, but now what we can do is plot the data. Okay, so what I'm going to do is I'm actually going to go up here and just nick this code again. But this time I want 3 rows of figures rather than just 1. And again, you can actually just nick this code again. And this time on the top plot, I'm going to plot the seasonal mean sea level cycle. Okay, and I'm going to give that title A of the seasonal mean sea level cycle. Okay. Now again, you can just cut and paste the code again, very simple. This one I'm going to put the interannual. So here I'm going to call this B, and this is going to be my interannual component. Let's be consistent, let's call that the seasonal component, and then I'm going to do a final plot This is going to be C, and this is going to be the longer term trend. So here I'll just call this one C, the long term linear trend. So we can run that and have a look. Now what I'm going to do is just change the colors. I forgot to do that, so I'm going to make this one red, this one blue, and this one green. I'm going to run that. So now you can see we have a really nice figure of the data set. So you can see that there is quite a bit of year-to-year variability, probably, you know, almost 40 centimeters. We can have a look, of course. There's definitely a trend of about 20 centimeters, and you can see there's quite a strong seasonal cycle, which in the second part, in step 5, we'll look at that and analyze that in detail.